Okay, this is Jeff Mucci with RCR Wireless News. Today's Analyst Angle Webinar will be on network function virtualization, and our analyst today is Monica Paolini, who is the president of Sensafili Analyst Consulting Firm in collaboration with RCR. Monica recently published a report on the NFV ecosystem that included interviews with KBPI, Telefonica, AT&T, as well as 7 or 8 industry-leading companies. The program consisted of a report, profiles on each of the companies, video interviews and transcripts of those interviews, and the report, the profiles, and the transcripts are available on RCR Wireless News under Reports. So at this time, I'd like to walk through the agenda and then introduce Monica. Today's agenda will go through her overview of the NFV ecosystem. We'll pause for questions on the presentation, and then Monica will go through reviews and profiles of our underwriting sponsors, and then we will open up again for questions and answers. So, Monica, at this time, I'd like to turn it over to you. Thank you for joining us today.
Thanks, Jeff. It's a pleasure to participate in this webinar, and this is the first report that we have written in collaboration with RCR Wireless. So it's again great to be here, and welcome to all of you. And what I'm going to do is the following. The report is quite long and detailed. So what I'm trying to do today is to give you an overview what's in the report, the key findings, and then you can go ahead and read the report, which is available for free for everybody that wants to download it, and get into more detail. At the same time, because I'm going to go very quickly through a lot of the topics that I'll cover, feel free to add any questions. Please feel free to do so as you go along, and if there is a question that some question I'm going to try to take as I go, but most probably at the end. So I guess let me get started here with my presentation. Okay, so as I said, as I was working on the report ended up to be quite extensive because there are 11 interviews which are quite in depth, and then there is a market report at the beginning where I tried to collapse and concentrate the findings that I found during my research and in talking to both operators and vendors, and I came out with 10 different dimensions in which NFV is affecting mobile networks, and so this is what I'm going to use in this presentation as well. When I started writing the report, I thought, well, there's so much hype on this, and I'm going to find out that actually it's not all that much of a big deal. But as I was talking to people, what I found out was actually the absolute opposite, that it's really there is some element of hype, but we're really getting to a point where there is much more reality. Things look much more real and closer to deployments, and we've seen a lot of proof of concepts trials going on very well. The initial announcements about deployments. So everything it's going well, but it's not going to be an easy process. So I think that the hype is leaving its place to a more realization that there is a lot of work to be done. It will be done. There is really no alternative to that. The question is how to do it. And so what I do in the report is to try to understand what are the trade-offs. What are the choices that operators will have to make, and vendors as well. And so this is why there are the 10 different dimensions with the 2 polarities, because a lot of this is about different options and different changes and directions in which operators and vendors can go. So let's start with physical and virtualized. So we're moving from classical to a hybrid and virtualized networks. And sure, that seems like that's the way the industry is going. There is no more much of a question in that respect. But the path, as I said, it's slow, and we're going to go from the classical physical network to the virtual network. There's going to be a hybrid network phase. And during this hybrid network phase, it's very important to get it right, but it's going to be a very complex phase because we're going to have the classical network and the virtual network coexisting. And to coexist in different ways, and one is going to go from, we're going to go from one to the other gradually, and so the scope will change. Different functions will be virtualized as we go along. The operations that have to support this transition will have to change slowly and gradually, so the operators at some point need to be able to do both at the same time. The cost will also go down, but really the real cost savings you have the real cost savings when you get to the virtual network. And the innovation cycle is going to become faster, but again, it's just going to be a transition. Now, so moving forward is one of the dimensions is are you going to work on the user plane or the control plane? And what are the functions that should be virtualized and which ones should not possibly be virtualized? So this is a list of functions that can be virtualized by ETSI. And ETSI has been doing an incredible amount of good work in this direction in terms of setting the requirements for NFV. Not the standards, which is really interesting and surprising, and I'll get to that later. But so there are a lot of functions that can be virtualized, but it's we still do not know exactly how far we can push it. And initially, it's the control plane functions that are going to be the best candidates for virtualization. And this is because they require more intensive CPU processing and limited bandwidth. So at this point in time, when the NFV maturity is still growing, those are the functions that both operators and vendors feel more comfortable virtualizing. And generally speaking, we are moving from a situation where you will have different parts of the network that are virtualized, different functions, and then move to the overall network virtualization. And it's a little bit like, if you want, it's a little bit like cheating, because if you only virtualize one function, the impact of virtualization is going to be very limited. So it's not really the end result. But in order to get to virtualization of the whole network, you have to start somewhere. So there is a lot of work that needs to be done. So we're going to see a lot of single function virtualization, which is not really quite what you want at the end, but that's really where a good way to start, well, the only way to start really. And so different operators might go at different speeds, but you know, the initial phase might be a little bit, how can I say, not disappointing, but you know, the impact of virtualization is going to be much more contained. Now, the other one is core and RAN. And I think this is quite fascinating because we are seeing that we see the boundaries between the two blurring with NFV and virtualization. So most of the functions that you initially think about in terms of virtualization happen in the core. However, there is a lot of work in the RAN as well with the move to CRAN, to Cloud RAN. And this is interesting because it gives the operators a way to put the two become closer to each other. They can become much more coordinated. And this is really important because it gives operators a way to optimize the network, which is much more powerful. But it's also something that can only be done if the two communicate. And traditionally, the core and the RAN have been quite separate. And I think that now this is coming to an end. How is that going to happen? How fast? I think it's a matter of debate. But it's it's one of the parts which I think is mostly innovative about the move to NFV. Obviously, you can do a lot of this optimization even without NFV or CRAN, but that just makes it so much easier. Then there is another topic that it's being debated a lot is the function orchestration. As I was saying before, there is initially we expect to see single functions to be virtualized, and then only at the end you get to the full network virtualization with end-to-end orchestration. And this graph, this is the ETSI graph that I'm sure you've seen before that shows the overall architectural framework for NFV. And the part here, this part that you see here in a vertical, right now basically sits here, here, and here. So the orchestrations happens basically at the single function level. That's clearly not ideal. But that's where we have to start, and this is the part that is becoming mature earlier. This is the one that needs more work. But this is also where the reward is, the main reward for virtualization. So start here and have the orchestration, which is tied to specific function, and then move over to orchestration. Now, when you full network orchestration. Now, as you get here, then this part that it's in gray because ETSI is not really working. Well, they're doing increasingly more work on this end, but initially it was excluded. But the whole issue of how the orchestration and management part relates to the OSS and BSS is going to become much more important, because this is where the legacy is, and so this needs to be also brought in. And there is a question as to the boundary between the two, what will happen to them. And so that's another interesting topic moving forward that people debate more and more, and that's you can see why this is quite crucial, because it's the way that NFV interfaces with the parts of the network that are less virtualized, yes, but eventually they'll probably go that way as well. The centralized distributed, that's possibly the latest. One of the latest topics of conversation is still not debated all that much. So when you think about virtualization, the image that comes to mind is a big data center. So there is sort of like an assumption of having more centralized functionality rather than distributed. And that's to some extent that might happen, but there is an interesting discussion and an interesting debate going on as to what should be centralized because it's more efficient, and what should be distributed because of the advantages that it gives you. So, for instance, well, there are obviously like CRAN, Cloud RAN type of virtualization that are so by definition at the edge. Then there is a virtual CP. Well, that's edge and core. But also there is a question: if you want to do, for instance, caching, where do you put? Where do you locate? So virtualization frees you, allows you to abstract from the physical implementation of functions, but it doesn't mean that it's not the end of location. Location is still important. It's important for things like latency, for instance, latency, performance, quality of experience. So I think that this is going to be an area where there is going to be much more debate, and different operators will find different solutions depending on how their network is structured, what their NFV strategy is, and how do they want to differentiate from each other. Because I think that we have to also remember that the NFV gives you a lot of flexibility, but also with flexibility comes complexity, which is undesirable in many ways, but also it's a way to differentiate from others. So that's that's a valuable thing. Now here, this is from Telefonica, and that shows you how the different functions might be more centralized and distributed. And I'm sure that as we go along, we will see more of those graphs and different operators taking different views. But this is an interesting starting point from one of the operators at the forefront here. Then another one is SDN and NFV. They always, mentioned together, and I think it's the report focuses on NFV, and that which is basically decoupling software from hardware, and that's the first step. But truly, to take full advantage of NFV, you need an SDN as well, which allows you to decouple control plane from a data plane. So it's only when the two come together that operators fully realize the benefits. And really, most operators are going for both, although different speeds, and the priorities are different, the strategy are different. But it's important to have the two together. Then there is the telco IT issue, and this is a cultural issue, and I think that we cannot stress enough how important this is going to be. There are new skills that are needed, but it's not the type of skills that you can send your staff for 1 day of 1 or 2 days of training, or 1 week, and then that's it. It really requires a cultural change from top to bottom in terms of the way you deal with things like change, reliability. It's a very different mindset than operators have traditionally. And this is going to require change, because it's not just a budget item that needs approval, or it's the deployment of a new solution. This requires changing the way people operate and think, and that's always more complex. Now, continuity and change. This is somewhat linked as well. With NFV, we're seeing a move from standards to open source, and this is why it's remarkable that ETSI is actually not working on an NFV standard; it's working on NFV requirements. And then there are a lot of open source initiatives to support NFV, and this is because the pace of change is changing, and so it's the change is incremental, it's faster. It's open to more participants. You don't have the standard release. You have more of a continuous process, and this has a lot of implications, which again will affect the culture of the company. Then TCO and agility, and I as I was working on the report, I was questioning, when as operators move to NFV, what's the major driver? Is it how much money they save, or they improve in functionality? In truth, you want the two together, and it might be an artificial differentiation between the two. But if you think about the full path to virtualization, it's a long one, and there are going to be cost savings, but they're mostly at the end, and all the benefits. So I think that if you, as an operator, just look at the cost savings at the beginning, where you have individual functions that are virtualized, you're going to have a very limited view. So from talking, especially from operators like KDDI, for instance, stress the benefits, the long-term benefits in having a more efficient network. And then optimize or monetize. I think that here there is what NFV does is it enables for a differentiated utilization of network resources. It gives operators a better way to decide what to do with what they have. And what they can decide is to say, well, we want to have more revenue, so we increase the investment in that way, or we can increase the profitability of the services by increasing the efficiency and keeping the cost down. And I think that different ways, and to some extent, operators might choose for different types of services or different parts of the network, one or the both of them. But I think it's something to keep in mind, because you don't necessarily reduce the cost, but you might be able, as an operator, to do more with the same level of investment, because you're able to use your network resources more efficiently. And this is the end of the first part of my presentation, and I think Jeff might have some questions, and any questions that you might have, I'll be happy to take.
Thank you, Monica. I appreciate the overview and the 10 dimensions. I did have a couple questions, and I think we've got a couple questions from the audience, and I encourage the audience to please submit your questions. So the first question I had goes back to I think it was slide 3 on the user plane and control plane. You mentioned layer 4. My question is, why is layer 4 important to the NFV prioritization strategy?
Well, it's actually here, it's layer 4 and above. So basically, if you go to the lower levels, which is what you do, the basic router functioning, is that you treat all IP traffic the same, and you try to do, you might have quality of service and so on and so forth, but you're just moving packets. And as you move to layer 4 and above, what you do see, what you can do, you can be more intelligent in the way that you treat traffic. So you differentiate the way you treat traffic based on what traffic you have, what type of application. And this is really important, because going back to the fact that you have a differentiated allocation of resources, you know that your resources, your network resources, are finite. No matter how much capacity you have in your network, the more capacity you have, the more capacity you need to meet the demand. So you have to prioritize and decide how to use it, what's the best way, so that you're going to pack the same number of packets. So maybe your traffic is the same, but because you can use it in a more flexible way, knowing what kind of applications go through your network, you can actually increase the quality of experience, and you can increase your at the same time your revenue generation potential, because you use your resources in a much smarter way. Now, obviously, that comes with more complexity, but that's exactly what we're talking about. You should be able to do with an NFV type of approach.
Okay. And then the title of this slide, it talks about user plane and control plane. Are those two different things, or one thing said two different ways?
No, well, the user plane is a data plane. So basically, it's all the data, the bulk of what is transmitted over the mobile network. The control is the way you manage that traffic, and with SDN, the two will be even more separated, and the type of requirements are different, because with control plane you have more intensive CPU processing but less bandwidth. Data plane, user plane, it's the other way around. So control plane is the kind of functions that lend themselves to be virtualized sooner. So the issue here for the operators and the vendors as well is, you want to go. This is a maturing field. So as the industry matures, you want to pick the functions and that are more effective, that you can implement with less disruption. So I think that's what we're seeing here.
Okay. And one of the notes was one of the viewers did not see DRA in the list of virtualized nodes. Was there a reason for that, or where would you see that fitting in?
Oh, well, that is clearly part of that's the signaling part, I guess, in the ETSI list. But yes, all the signaling. I mean, and this is this is crucial, because this is all the there is a lot of optimization that can be done in that direction, and that's where there is a lot of potential for NFV. Well, the interesting thing about NFV, when you think about it, is that it doesn't make it doesn't create new functions. You just do the same thing you're doing before in a different way. So there is really nothing intrinsically new. It's just the way you do it. And I think that's where you can obviously optimize signaling no matter what. But in a virtualized platform, you should be able to do it more efficiently.
Yeah. And one of the other questions we have from the audience is, I think it was on that final slide you mentioned the CapEx goes down with NFV, but OpEx goes up. And maybe I just want to clarify that comment, because if OpEx is going up, how does that tie into the efficiencies that would be gained over time?
Yeah, so this is okay. So the net gain should be positive. So you should have cost savings. So that's the idea. Now the cost savings are going to become more substantial as you move into this part, because then you can really share resources among many functions. So this is where the true efficiencies come in. Here, the cost savings are going to be much more limited because you only have parts of the network that are sort of virtualized as islands to themselves. But in terms of the capex and opex distinction, what you're doing now is that let's say you want to deploy a new solution. So you buy the hardware, and you might also pay for licenses, but you need to have an investment in the hardware and in the solution. That doesn't really scale very well. Now, the idea is then with NFV or virtualization in general, instead of making that initial purchase, you just buy the license. And so that model scales much more tightly with demand. So as your number of subscribers goes up, or the traffic goes up, or whatever the metric is, you just increase your OpEx expenses because it's tied to this to the licensing model. So basically, you see a shift from CapEx to OpEx. And as I said, it should be also that the overall total, the TCO is better, but this allows operators to avoid the upfront cost and have the cost for the same solution to be spread through time and tied to demand. So this is something that operators like quite a lot because they don't have to have a big initial commitment. It's more spread through time.
Yeah. And I think if you look at the way carriers deploy their networks today, they have to buy hardware in a very distributed fashion, which results in different software releases that need to be upgraded over time, or you'll see a surge in demand in one geographic area, but you would have made a fixed investment in an area that may not be growing as fast. Mm-hmm. As such, with NFV, you basically pay for the subscriber growth wherever it is, and you don't have to worry about that forklift or stair-step capex in the field. But you didn't really talk about the software upgrades as well over time. This becomes much more efficient from a software upgrade as well.
Yeah, well, and the other thing is that as I say, you're not tied between the two, and another dimension to add is that the software upgrade might happen at the time that is different from the hardware upgrade. So the sort of the technological advances in hardware and software are not tied to each other by and large. So that you might decide to upgrade your hardware at a different time than your software because it just happens at a different time or because you have different needs. So the two are separated not only in space and need in terms of what your subscribers need or what your network does, but also in terms of what's available from a technology point of view. So it just reduces cost, and again, this is quite difficult to quantify because you don't know exactly how the hardware evolution goes and the software evolution goes. So it's very difficult to quantify, and I found it very hard throughout as I was preparing the report, when I was trying to say, well, let's try to quantify how much of a cost savings will you have. It's really difficult because a lot of those cost savings come from something that is really difficult to predict, that you can see that it's going to be there, but it's really difficult to put a number in it, on it. And this is a case where you have a different upgrade path for hardware and software. Yeah. That gives you a lot of flexibility and hence cost savings.
Yeah. Well, if you could go back one slide, I think it was one or two slides, where you talk about the separation between the core and the core and the RAN. I guess several slides back. One of the questions we have from the audience is as follows: would a CRAN approach be the only feasible path for NFV to be applicable to small cells? And when can NFV be really expected to reach small cells?
Well, the Small Cell Forum just started to work on this, and I think we will see much more later. This is an area of this is really, we're moving the first steps, because there are not that many small cells out there in the first place. So there is a lot of learning to do. If you want to do CRAN for small cells, you need to have a fiber or fiber quality backhaul. So and that can be challenging in some locations. But on the other hand, if you have a co-channel small cell deployment, you need to coordinate the transmission well enough to avoid or to manage interference. So there might be other solutions. I think that in the same way that we see that the small cells are the whole set of equipment and solutions are different. You are seeing a whole range of solutions from small cells to DAS. There's a lot of in between. So there is going to be a lot of different solutions that are not your standard CRAN. Although I'm saying standard CRAN, but what is standard CRAN? We don't know yet, because we're sort of like developing as we go. And again, with CRAN, how much you want to have it centralized, how much you want to have it distributed. So yes, I think there is going to be a lot of a lot of opportunities. In fact, I'm working on CRAN. Is going to be the topic of my next report, because it's really fascinating in terms of what opportunities it opens. But it's not. I don't think we have all the answers yet.
Yeah. Well, it's interesting. Several weeks ago, I attended the CompTel show in Dallas, where you've got a lot of the metro fiber and long haul fiber folks selling on a wholesale basis. And then last week I was at the HetNet Expo that's produced by the Wireless Infrastructure Association, and one of the things we heard clearly at CompTel was that one of the top two mobile operators was aggressively signing dark fiber deals across the U.S., and that owning dark fiber was a core part of their CRAN strategy. So I was just curious, as you look at this slide, do you have a sense for how CRAN is changing a carrier's fiber strategy, and what some of those topographies might look like?
Yeah, it is quite interesting, and I guess the question is also how the fiber strategy is going to inform their CRAN strategies. So there is an impact on both ways. So if you look in Asia, for instance, in Asia there's a lot of CRAN already. There's been some for some time, because they have much more fiber. A lot of operators have fiber and mobile networks. So it's in that case, it's the obvious solution. There is a lot of advantages, and so in that kind of environment, CRAN is much less of a debated issue. In U.S. and Europe, it's a newer issue, and I'm sure that for operators that changes. They can be much more efficient in the way they run their networks. It's not going to be an overnight change, but I think there is a lot of opportunities there. The question is, different operators have different type of access to fiber, and if you only have fiber to some of your assets, then a CRAN is not as good as an option. So I think that there is going to be much more interest in terms of ensuring that they have fiber or fiber-like. You can have a wireless front haul as well. So to have that kind of infrastructure in place, so that then you can enable Cloud RAN. So the fiber strategy, in a way, it's step number one to ensure that you have your ground is covered. You can actually do CRAN. So I think that this is a very good sign, and it's a very interesting one as well.
Okay. Well, let's. I think it's important to note that this in-depth report on NFV is provided free and complimentary, and it's available on Sensafili's website as well as the RCR Wireless News website. What we're going to do next in the next session is Monica's going to walk through at a high level what some of the underwriting sponsors are doing from an NFV strategy standpoint, and talk a little bit about each one, and then we'll have another Q&A session at the end. So please feel free to submit your questions as Monica goes through the next part of our presentation.
Thanks, Jeff. So I have 11 slides here covering all the interviews. Interviews are quite in-depth, so I'm not going to cover everything. There are some quotes here, but I'm not going to read them. I'm just going to give you a little bit of a sense of what is that the interviews were about. I have to say that that was in many ways, that was the most fun part in writing the report, because the interviews are not scripted, and we had the opportunity to expand and to look at different parts. So the report is on the ecosystem, and so here what I've done is to talk to vendors and operators that look at this issue from different viewpoints. And if you read them all, you will see that there are some commonalities, but also there are some very different challenges. And I think that one of the things that I did not mention before is that with NFV, as you basically dissociate function from hardware, what happens is that as an operator, you have more flexibility, but everybody in the ecosystem have to work much closer to each other than they used to. When you have a vertically integrated solution, you, as a vendor, you move in, you install everything, and you're done. As an operator, you make sure everything works, and then you're done. Well, I'm simplifying a bit here, but I think you understand what I'm saying. You are in a virtualized environment where your solution works on somebody else's hardware. If something goes wrong, whose fault it is? So from an operator point of view, how do you measure? How do you monitor your network? How do you make sure that everything works as well as it possibly could? And so what we're seeing, what you see throughout the interview, I think it's the most interesting one. One of the most interesting points is how everybody realizes that it's really crucial to get everybody to work together. And this is why I think the open source component is very important, because it allows a much more continuous type of collaboration between among the players. And so so what I'm going to do now, I'm going to be really quick so that you also have more chance for questions to go through the different interviews that I did. So Telefonica, first I'm going in reverse alphabetical order here. Telefonica is one of the most aggressive operators on NFV. They've been doing work in Brazil. They plan to have 30% of the network virtualized by 2016. And it's interesting to see how important a big shift they see NFV to be, and what is going to enable them to do. Then we go to Spider Cloud Wireless, and this is interesting because as you were talking about small cells, this is a small cell solution enterprise, and this is a case where NFV is pushed all the way to the edge, because there are a lot of services that just happen at the edge. So it makes sense to run functionality there. And then we go to Virtualized Wireless, which is taking somewhat of a different approach, because it is true that some services are better run at the edge, but some services are better run in a more centralized location, and what that does is facilitates the offering of managed wireless LAN services. And this is important because it gives the operator the ability to reach smaller customers or smaller sites, which if they have to manage on the location, they just become too expensive. So you can see here that we have two vendors approaching the issue of the enterprise issue from two very different perspectives. And then we go Metaswitch networks, and here the focus is on the IMS core. IMS is one of the functions that are the sort of prime candidates for virtualization because they're very signaling intensive. So that is that is one of the first functions, and so session border control as well is another focus. And the Metaswitch has a big commitment to, again, open source, although that is true pretty much of anybody that we have interviewed. Let me go. Next, we have Mavenir. This is virtualized VoLTE and RCS functions. Again, IMS based. So one of the very first functions that are virtualized. And again, this is at the beginning, the IMS, VoLTE, RCS functions are going to be more on a standalone basis, but then they are designed to fit in and to eventually be part of a bigger and network-wide virtualization effort. Then KDDI, we talked to KDDI. That's the second operator. It's interesting. It was interesting talking to them because they really see NFV crucially as a way to make their network more capable of dealing with the high levels of traffic. And I think that in Japan they're seeing that even earlier than we are in North America or in Europe. And so that's really the key drive for them. They obviously want to have cost savings as well, but this is really what's driving them. Juniper, here they are working at different levels at the single function and level, but also with MetaFabric at the data center architecture and the NFV platform. So they're working on multiple levels to enable an open NFV environment, and this is really important to have an environment that is open. This is really the core value of the core driver for virtualization, especially from the operator point of view. JDSU, that's another interesting interview, because here what we talked about is the monitoring analytics in a virtualized mobile network. So you virtualize everything, so how do you keep track of how things are working? What is the impact on customer service assurance? And so these are all very important questions that oftentimes are not, they're not the first thing you think about virtualization. You think about the cheap hardware, but the issue is that how do you make sure that everything works? And if something doesn't work, which is bound to happen at some point, where is the problem coming from? How do you locate it and how you address it? Intel, they obviously have a huge presence here as well. And we talked about among other things, about the way that Intel is working with all the ecosystem players in order to optimize the hardware. Now, just because it's off-the-shelf hardware that is not being developed for a specific solution, there is still a lot of work that can be done to optimize the functionality. So that is also quite interesting one. And I think this is the last one, Hitachi. Here we're moving again to the RAN, towards the RAN. We're still in the core. They have an MME SGSN solution that is optimized and that allows the operators to have both MME and SGSN functionality, and to do that in a virtualized environment. And that, again, gives all the flexibility that mobile operators need in order to increase capacity where needed and when needed without having to plan too much ahead. And I think that's it. So I guess we have some time for more questions. Oh, no, sorry, I forgot, AT&T.
Okay.
So, sorry, let me finish. AT&T, that's another very aggressive player on NFV. One of the interesting parts that we discussed in the interview is how the move to NFV, to virtualization, is going to not only change the way to provide the services, but also how they need to operate internally. So it's the relationship with vendors change, but it's also the relationship within internal groups. And that's really it.
Okay.
Yeah.
Well, we've got about 10, 15 minutes left here, and I've got some other questions that have come in, and I encourage people to please submit your questions. We'll go through them as best we can. One of the, I think, the logical questions, especially when you have hype around the technology, is whether or not some carriers can just continue on with the traditional network architecture versus migrating to NFV. Is that possible?
Yeah, and I think that for a lot of operators, especially maybe small ones in some emerging countries, you're not going to necessarily move to virtualization right away. But eventually, that seems to be the way to go. But I guess it's sort of like 2G. I mean, it's clearly we're all moving towards 4G and eventually 5G, but there is still a lot of 2G out there. So I think that there is going to be a lot of difference in terms of the pace of innovation, and also what is being virtualized within that strategy. So we'll see a lot of difference. What's interesting is that you might think that, or at least initially I thought, well, big operators are going to be the ones that are moving faster. But there is also an argument that some of the interviewees make that smaller operators stand to gain more from virtualization, and they're more agile. So they might actually be the ones moving first. Not all of them, but some might. So it might be interesting to see who moves first and what's going to happen.
Okay, but again, tied to that question, Monica, is there a cliff, technology cliff, or an operating cliff in the future that will fundamentally require all operators to move to NFV? Because it's different than 2G and 3G in so much as LTE doesn't require virtualization, LTE Advanced doesn't, and VoLTE doesn't require NFV. But am I missing something? Is there a cliff there that is going to force everyone into the NFV world at some point in the future?
Well, not in the short term, but I would imagine that in the long term it's going to be difficult to, I mean, a lot of vendors will just have a virtualized product that is going to be their product, and everything else is just legacy. So if you want to keep up with innovation, that's why you do it. But in that case, you can basically have what you currently have today. So you just virtualize individual functions. So instead of buying a certain function that it's using dedicated hardware, you just use off-the-shelf hardware. It's not really fully virtualization, but it's halfway through. So, but it is also true that I don't see any reason why they really have to do within the next 5-10 years, and otherwise they will not be able to run their networks.
Okay, we skipped over one of the more important buzzwords in today's discussions, and that is the word of orchestration. Maybe you could jump back to that slide and address what is orchestration, and at what point does orchestration have to be introduced? Is it an absolute must on the front end before you introduce your first NFV, or is it kind of midway up the slope or at the end? And then what exactly is it? Is it hardware, software? Where does it sit? Is it a third-party outsourcing? What is it?
Wow, that's a big question, and there is a lot of debate on when we're going to get there and how does it count when we get there, or do we have it already? So basically, once you abstract software from hardware, it sounds all very good, but somebody has to manage. Somebody has to, something has to decide how to allocate resources, how to manage the whole flow. So there is the moment you start moving towards NFV, you need to have some level of orchestration on day one, because you need to manage that type of, you have to manage the virtualized network, and that's what the orchestration and the virtualized infrastructure does. So, so in a way, orchestration is here today, but it's really specific to a function. So oftentimes when you have a function, and some of the vendors, if you read the interviews, they talk about that. They basically do the orchestration and management within that function, because that's all. It's virtualized, so it makes sense to have it sort of say local. But if you imagine going along that way, where all the orchestration is done in this kind of silos, well, then you sort of you don't get any the real advantages of virtualization. You just have a fragmented approach. So clearly, that's not the way to go, and nobody wants to go that way. So this is just the first step. So the idea is to have an orchestration and management approach that it's an end-to-end for the network. And as we go through the transition phase, the orchestration also has to take into account the fact that some part of the network is going to be a legacy network, so it's not virtualized. So it's quite complex, but it's clearly that's clearly the goal. But it's also the part that it's more less mature. There is more innovation, more work that needs to be done. So it's difficult to really know exactly. You can say, well, next year everything, mature solutions will be available. So operators are basically trying to go gradually and expand gradually the sort of the orchestration functionality. Does that answer your question?
To some degree. So going back to your comment about today, orchestration is embedded in a specific function, and so I assume you mean something like a vol packet core or a diameter signaling package, software package or function would have an orchestration function or capability built within that application. And so today, if I'm in the NOC or somewhere in the provisioning, I'm closing one screen and moving to another screen and then moving to another screen, kind of the ultimate swivel chair from one orchestration package to another. Is that the way it's done today? And then what you'll see over time is an orchestrator of orchestrators that'll sit on top of all the other either virtual or physical non-virtualized applications. Yeah,
you're absolutely right. And so we're going to see that. And again, right now, because it's a single vendor that does the function and the orchestration, the issues with interoperabilities are clearly limited or non-existent. But then as you move forward, then there is all the issues in terms of having the different pieces working together. And that's going to be, that is a challenge right now already, because if you had a vertically integrated network, then the orchestration part would be much simplified, but that's what we're trying to get out of.
Yeah. Well, what does this mean for, say, the big core vendors and the big RAN vendors? do they have to cannibalize themselves to be a leader? Or, what does it mean for the big guys, if you will?
Well, I think that means that they're going to be forced to innovate faster because the new entrants or the companies that come from the IP world, sort of the wireline IP, are going to become more present, and more operators might be more responsive to talking to them. So, they're going to be under, more challenged to innovate at a faster rate. And again, this sort of goes back to the culture issue, where in the telecom side of the business, there is more of a need to ensure reliability and sort of a slower pace, more a different approach. And on the IP side, there is much more flexibility, more fluidity in terms of the evolution patterns. So there is going to be more pressure to evolve, develop new products, and to work somewhat differently. On the other hand, it's not going to be. I mean, the tier one vendors have gone through a lot of changes quite successfully. Maybe not all of them with the same success levels, but they're clearly seeing it, and they're clearly responding very aggressively to the operator's requirements. So, yes, they're going to be, pushed to innovate more quickly, but it's not like they're going to disappear tomorrow because of virtualization. So.
Okay, and then if you end up with all Linux servers and generic servers and open source software, is there a danger in that that the network's not optimized for any one function? In other words, you get reduced performance and power consumption because of everything's generic.
Yes and no. So yes, to some extent, you're going to the solutions are going to, well, most of them at least, are going to be less optimized because they're not, the hardware is not custom made for the function. So you're going to see some reduction, but that can be made up by the fact that you can you can use brute force from the hardware side. So that's sort of that's one answer, but really the other answer is that you can optimize the way your solution work on off-the-shelf hardware. So it's a different approach. If you're developing a solution, instead of working with somebody that customizes the hardware, you work with the hardware you have and make sure that your application works the best it can with the hardware. So it doesn't necessarily mean that it's all going to be generic. And also, even though the core, a lot of the interfaces, the API, and a lot of the sort of the plumbing of the system, if you wish, is open source. There is a lot that is not going to be open source. It's going to be built on top. That's going to be something that operators will pay for. So it's not a free-for-all type of solution. And in terms of services, there is still going to be, the vendors can still provide support for the software, even if it's open source, as a service. So in that sense, it's not going to be as disruptive as the thought of the data center full of Linux servers would conjure.
Okay, I'd like to close on one other topic, and it deals with the northbound APIs, moving from a traditional network architecture to a truly virtualized architecture. Today you may have this one-to-one connector, and then you move to one-to-many connectors, and then ultimately you end up with many-to-many or multi-to-multi connections across all these different platforms. What kind of sense did you get from the carriers and the vendors about how they're dealing with the northbound API to avoid siloed systems?
Well, that is an issue that is going to become much more important as we move along. I don't think that we really have an answer to that. This is part of, there is a lot of issues here in virtualization that we don't really know how to deal with. It's basically a trade-off between the richness and the flexibility on one hand, which is desirable, and the complexity and the fragmentation on the other. And I think that there is a need to find a balance. I don't think we have it yet.
Okay. Well, it's 2 o'clock, and I just want to thank you, Monica, for your leadership in this webinar. I thank the sponsors for underwriting the program so we could offer it complimentary, and a thanks to all the attendees and the great questions we have. Please feel free to send Monica or me questions. Monica, if you could jump to your last slide, I think it does have your email. And again, the report is available on the Sensafili website, and it's also available under reports on the RCR Wireless News website. Monica, thank you very much for joining us.
Well, thank you very much, Jeff. It was a pleasure to be in the webinar.